limits of continuity. We said before that the continuity, we can say that the function is a continuous at x equal a as an example if the function is defined and if the limit is exist, and also if the limit f of x is equal to the value of f of a. For if these three conditions are satisfied, accomplished, we can say that the function is continuous at x equal a. Now, and also we deal with this continuous or limit of continuous continuity with the graph, as you see here. We say that at limit f of 2, limit x when x approaches, or f of x when x approaches 2 from the right, as you see, it was 4 as an example, and 2 from the left, it was also 4, and f of 2. So because of that, you can say that the limit exists. Now, and f of 2 is equal to 3. It's defined also, but the limit is not equal to the f, so we can say that the limit is not continuous. By the graph, we can know that if this shape is continuous shape or not. Now, today, we will talk about this, or how can we find the limit of continuity by using the piecewise function. From here, if I have these points, as you see, now what are the changing points here? It is 1 and 2, is it right? The changing point here is 1 and 2. So I want to check now if the graph or if the function is continuous at point 1 and at point 2. So I want now to check if the function f of x is continuous at x equal 1 and at x equal 2. Let's start now with the function at x equal 1. I want to check if the function is continuous at x equal 1. How can I check if it's continuous? Who can tell me? Grade 11, are you here?
Yes, Miss.
Yes.
Okay. How can I know the function is continuous at x equal 1? What are the three things I have to check?
If the limit is equal to the function first.
So the first step, I have to find f of x. Then I have to find the limit. Then I have to check that f of x equal to the limit. Let's see all of these three conditions if are accomplished or not. Look at the first one. Find f of 1. To find f of 1, I will go to number 1. Here we have 1, and here we have 1. Okay, then my next question. Where's the equal sign? Is on the first or in the second function?
The second one.
Second one, thank you. So I will use this function, and I will say 10 minus 1 equal 9. So f of 1 is equal 9. Okay, so the function is defined. Now, the second one. Let's find now the limit from the right hand and from the left hand and check if they are exist. Look at one from the left hand. Left hand, I mean this function, is it right? X squared plus 3. Now, to deal with it, I choose 1. I don't choose 0 or -1, number less than 1. I choose number 1, but this function. So I will say 1 squared plus 3 equal what? Equal 4. And what about one from the right? Which function I have to use?
The first one.
Second one.
The second one. Here. This one. Sorry. This one. This one is a function I have to use if x is greater than 1. So I will say now 10 minus 1 equal. Now, does the limit exist?
No, the limit does not
No.
exist.
It doesn't exist. So my second condition was not accomplished. So I will stop here. Sorry. So I will stop here now without continue, and I will say that the function is not continuous at x equal 1. Is it clear?
Yes.
Yes, teacher.
Yes, teacher.
Let's see now the second one. Now, I want you now to check if f of x is continuous at x equal to. Let's see now at x equal 2. Let's find f of 2. F of 2. Which function I have to use, the second or the third one?
The second one.
The second one, thank you. So I have to say that h minus 2 equal 8. So the function is defined. The second one, I want now to find limit f of x when x approaches 2 from the right, and also limit f of x when x approaches 2 from the left. Yeah, let's find 2 from the right. Which function I have to choose?
Third function.
Third.
The third, thank you. So I have to say 6 minus 2 squared. 12 minus 4 is equal to what? 8. Let's see now 2 from the left. Which function I have to use?
The
Second function.
The second function, thank you, which is h minus 2, 10 minus 2 equal 8. Now, is the limit exist? Or does the
Yes.
limit exist?
Yes, the limit
Yes.
exists.
Yes.
So I can say now the limit exists. Okay, then the third step. The second step, the first step, the function is defined. The second step, the limit is exist. What is the third step? I have to check what?
The limit equals the function.
Thank you. I have to check now if the function is equal to the limit. What is the function, the value of the function? It is 8.
8.
And what is the value of the limit? It is 8 also.
8
Are they
also.
equal?
If it's continuous.
Yes.
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 So I can say now the function is continuous at x equal to. So a conclusion that the function is continuous at x equal. This will be my conclusion. Is it clear now?
Yes.
Yes, teacher.
Okay. Who opened now the virtual classroom from iPad?
Not me.
The others? From where you open the virtual classroom now?
Laptop.
Laptop.
Laptop. Okay. Anyone have a touch laptop? Does anyone have a touch?
Yes. I have.
Okay, I want you to solve this one. Okay, just write in the screen.
Okay.
Okay? Yeah, let's
Okay.
write, please. Yeah, here now. If you have f of x equal 2x plus 3, if x is less than or equal 4, and 7 plus 16 over x, if x is greater than 4. I want you now to solve, to show to us how is if this function is continuous at x equal 4 or not.
Okay. بس أجرب أكتب؟
Yes, yes.
ما عم بكتب.
Rot. Try it right in
أنا
the
هياتني عم
screen.
بكتب.
The screen.
هي عم بسر. ما راضي.
طب choose another color. هلا first
Okay.
choose. Haidana start to write also. See here we have a draw. This one, choose the draw and write. See here you have word annotate, sorry. You see it? Annotate.
لا.
Annotate, you didn't see it? On your laptop.
Yes, yes.
Okay, press on it now.
Okay.
أيوة يلا, you have to start. أيوة يلا, you are right now.
Okay.
يلا.
Try to solve?
Yes.
Okay. طب if x equal what?
4.
Okay. Equal 11.
Thank you. So f of 4, this will be f of 4. So f of 4 is equal to 11. Okay. Now I want you to find limit. Okay, I will write here for you. Limit f of x when x approaches 4 from the right. And I want you also to find limit f of x when x approaches 4 from the left.
Okay.
Yalla, 4 from the right.
4 from the right. We're gonna use the first one.
The second one, thank you. Yeah. Thank you. So 7 plus 16 over 4. 16 over 4 is 4.
4
Plus 7
equal 11.
equal 11. Thank you. Now the second one, 4 from the left.
We're gonna use the first one.
Thank you.
Equal 11.
Equal 11. Now, does the limit exist?
Yes.
Thank you. So the limit here is exist. So the second step, limit f of x when x approaches 4 is equal to 11. Now what's done of the third step? You have to check that f of 4 is equal to limit f of x when x approaches to 4. Are they equal?
Yes.
Yes. So I can say that now the limit, the function
is continuous.
The function is continuous at x equal 4. Thank you so much, Lana.
Thank you, Miss.
Welcome. Do you have any question?
No.
Okay, thank you. Now in this one here, he told me that the function is continuous, but you have to find the value of the constant k that will make the function continuous everywhere. Okay? Here, he told me that the function is continuous. So what does it mean? If the function is continuous, that means the limit
equals the function
limit f of x when x approaches 1 is equal f of 1. Is it right? If I told you that the function is continuous at x equal 1, what does it mean? That means the limit is equal f of 1. Okay, so look at now here, this one. For this one, limit f of x when x approaches 1 is 7x minus 2. Kx squared. And f of 1 is 7x minus 2. Is it right? The function of f of 1 is which the function have an equal sign, which is 7x minus 2. And the limit is 1 without equal sign, which is kx squared. By now, is it clear?
Yes.
Okay.
Yes.
Then the second step, I have now x is 1. So let's now put instead of x, 1. So what I have now, I have k equal 7 minus 2 is 5. So what is the value of k? It is 5. So because of that, the function a, it will be like this. 7x minus 2 and 5x squared. I have to find k. How can I find k? By using the third condition, which told me that the limit of f of x equal the function. Is it clear?
Yes. Miss, can you repeat?
Okay. Here, he told me that the function continuous everywhere. So the function is continuous. What did I mean if I say the function is continuous? That f of 1, as an example, the first one, is equal limit f of x when x approaches 1. This is if I see or I say these statements is true, that means my function is continuous. So the function is equal the limit. Okay? If it's continuous, that means the function is equal the limit. It's okay now. F1, which function help me to find x when x equal 1? Shall I use the second or the first function? Yes, Shahid.
The second?
Use the first.
The first one, because we have an equal sign. I will write here 7x minus 2. Now for the second one, the limit. For the limit, before that, you have to check from the right and from the left. And since they are equal, so you have to choose one of them. Is it right? If I told you that the limit from the right is, or the limit is exists, I have you to go back. يعني I mean, my conclusion in the continuity that the limit, or if they are continuous, what does it mean? This function is defined and the limit is exist. How it will be exist? If the function from the right is equal to the function from the left. Now, how I can say now, well, it's one from the right, that's mean I have use this function, which is kx squared. And from the left, I have to use this function. Is it right?
Yes.
Okay. Right. If I write here this function, what do I need to write here now? The second one.
Second.
Because they are equal. So since now they are equal, so I can use this equality or this continuity of the function to say that what? To say that they are use the equality to find the function, the k. So 7 minus 1 times 1 minus 2 is equal to k times 1 squared. Why I say 1? Because x equal 1. So 5 is equal to k times 1 squared, which is k. So the value of k now is 5. So the function will be 7x minus 2 if x is less than 1, and k x squared if x is greater than 1. Is it clear?
Yes, teacher.
Okay. Now let's solve B. In B here we have the same idea, but f of 2, since they are continuous, so it's equal limit f of x when x approaches to 2. Okay? It's continuous. So what does it mean? That means the function which is defined equal to the limit which is exist. Where the function is defined? Where it will be defined? At which one? The first, the second, the first or the second one?
First one.
The first one at k x squared, because here you have an equal sign. Now, since the limit is exist, so what does it mean? That means if I choose the first function or the second function, I will have the same answer. Is it right? If I told you that the function is exist, what does it mean? Here, if you go back here.
They are equal.
Here, when Lana solved this and told me that the limit is exists. She first solved. Ya Allah. So she first solved the limit from 4 from the left, and then she solved limit 4 from the right. Is it right? And after she solved them, she found that both of them are 11. That means they are equal. That means they are exist. So if you evaluate number 4 in the first function or on the second function, you will get the same answer. Is it right?
Yes.
Yes. So what does it mean? Here, that's mean that if I choose the first function or the second function, I will get the same answer. I have the first function, I already chose it. So what I have to choose now? The second function. Is it clear?
Yes.
Okay. Then after that, what is the value of x now?
2.
It is 2. So now I will evaluate x with 2. So it will be 4k equal 2 times 2 is what? 4 plus k. So 4k is equal 4 plus k. Minus k. So 3k is equal to 4. So k now is 4 over 3. This is now the value of k. Is it clear?
Yes.
Yes, teacher.
The others?
Yes.
Sima, Maryam,
Yes, teacher.
Dana, and so on, and all the others. Tala, Darien. Is it clear?
Yes, teacher.
Yes, teacher.
Do you have any question? Shall I repeat anything?
No, miss.
No, everything's clear.
Okay. Now, by now, we finish our chapter, our first chapter, limit. Next time, inshallah, we will talk about the second chapter, which is the derivative. Okay?
Okay, teacher.
Yeah. Have a nice time.
Thank you. Thank you, teacher.
Have a nice
Thank you,
day.
teacher.